Good morning. We're standing here on the roof of the parking structure A in Los Angeles Mission College on a beautiful Sunday morning. We wanted to show you the new project that we have recently commissioned, the new photovoltaic project. Standing with me is Eric Rodriguez from Rodriguez Engineering. He's the brain behind the structural design of the project. And why don't we give you an overview of the project. Follow me. Okay, we'll tell you a little bit about the project. Essentially, we're looking at, what you're looking at is 3 bays of photovoltaic panels, and there are totally about 1128 panels, approximately producing overall about 170 to 180 kilowatt, depending on the position of the sun in the sky. The challenge in this design is truly structural in a lot of ways, because given the wind loads, given the height at which we need to mount the panels, given the seismic forces, one of the greatest challenges is how to build a structure that is not only visually very appealing, but it also has the structural integrity to support all the loads. I'll let you talk to Eric Rodriguez, or hear Eric Rodriguez from his point of view as to the challenges that he encountered as he took on the structural design.
The challenges that we ran into was that, number one, this is on an elevated parking structure, so we had to deal with the whiplash effect being at the top of the structure. Secondly, we designed the system such that because of the parking spaces, we had to design a cantilevered column system. What that basically means is we're relying on like a flagpole action where it's fixed at the base, and during a seismic event it will move like so, like a flagpole structure. We went through all the DSA submissions and approvals and peer reviews, and I love it because I see the structure. Usually it's covered by architectural elements, but here you can see the cantilevered columns that are curved and the supporting steel beams above that, which in turn support the PV panels over that. So from a structural standpoint, we transferred the loads from the top down to the base, down to the concrete pedestals, which we've coordinated with the project structural engineer for the parking structure in terms of the loads from seismic and wind that will be transferred. So it's an excellent structure. It looks beautiful, and Jay did a great job, and that's about it.
In this project, there are totally about 94 arrays. One array consists of 12 photovoltaic panels. Each panel can produce approximately about 44 volts and a current about 4.5 amps. So when we put them all in series, potentially we're looking at a voltage around 480 volts or 500 volts in that range. All the wiring that you see exposed, which is called the USE Type 2 wiring, that wiring goes into a J-box, and there's a J-box like this available for every 2 arrays. So wiring goes into the J-box, which you can see from here, rated at 480 volts, and from the J-box, the wiring goes all the way into what we call as a combiner. In the combiner, all the currents from the various arrays are combined into a single circuit, so potentially one combiner produces an output as high as 60 amps or 70 amps during normal load conditions, but they're rated based on the code requirement up to 100 amps output. So those are 100 amp currents go through the conduits which actually run through the columns. Now let's explain to you typically the parameters that we deal with when we design an array. One of the important things to deal with when we design the photovoltaic system is whether the array should be mounted flat or whether the array should be tilted at a certain angle. In the case of this parking structure, we chose to tilt the arrays at approximately 10 degrees. Now the reason is, ideally, you would want to tilt the array at the same angle as the latitude or somewhere around that number. But the problem is what happens when you have a high inclination, the arrays tend to cause a shadow sooner later on in the day when the sun hits the low angles. So it is always a balance between the tilt and the number of arrays you can accommodate along the length of the way. So we wanted to try to attempt to maximize the power production, at the same time accommodate a reasonable number of arrays along each bay.
I'm going to give you a little more descriptive on the structural system that we've designed for this PV system. The way we look at structures is a concept called load path. The load path is comprised of seismic, gravity, thermal, and so forth. we'll explain briefly the seismic and gravity. And if we look at a specific bay, which is a typical bay for this system, we have each of the panels that rests and